Could 15 be an input of the function? Why? What's 15 representing? Yeah, so which one is our function? Is our function so let's think about it. If we're looking at barks and seconds, do barks depend on seconds or do seconds depend on barks? Barks would depend on seconds. So that would mean my inputs would be seconds. That's my independent variable. So could 15 seconds be an input? Why? Because 15 seconds is a valid amount of time, all right? What about 84 and a half? Could that be an input? Is 84 and a half seconds a valid amount of time? It is. Can you not have half seconds? You ever had a half second? Quarter second? What's your 40? Hey, what's your 40? Or am I 40 and 3 flat? No, not quite. Okay. And then 300. Could 300 be a valid amount of time? What would we be talking about if it was 300? 300 seconds. It is a few minutes. How many minutes is 300 seconds? I heard it. 5 minutes. So it tells me the owner comes back and picks up the dog less than 3 minutes after he left. Which means the maximum input would be 180, which is 3 minutes. So anything over 180 would be unreasonable. So 300 doesn't make sense. Does that make sense to you? Why 300 doesn't make sense? It's not a reasonable input. Okay, what about outputs? So what are we talking about with outputs? How many times the dog barked? Could the dog have barked 15 times? Sure. Could the dog have barked 84 and a half times? No.
Maybe.
What did
If he gets cut off,
did he die mid bark? I mean, I don't understand. Half does not make sense with barks. What about 300 barks? Is that valid?
Yes. Could be a really
It is valid. Yeah, well, I've seen dogs like that. Okay. 2 barks a second for 3 minutes. That puts you at 360 barks. 2 barks a second, I mean. I think I said a minute. 2 barks a second for 3 minutes. I could see it. I mean, it could happen. Questions there? So let's just start here with the first one. What are my inputs? What are we talking about here as the input? Our input is side length. So we're looking for lengths of measurement in centimeters. So can I have -3 centimeters? No, not as a side length. So this would be impossible. -3 would be in your impossible list. Can you have 9 centimeters? It's possible. 3/5 centimeters. Possible. Right? 15 centimeters. 0.8 centimeters. 4 centimeters. 0 centimeters.
It's possible, but not in this situation.
I agree. If I had a square that was a length 0,
It wouldn't exist.
it's not square.
It's not there.
So 0 doesn't make sense there. What about 25/4?
Yeah.
That's just a fraction.
Don't know why you write it that way, but yeah.
That's the way I would write it. Well, I guess I could make it a decimal.
Probably.
6.25. 0.001.
I say no because if you square it, you get a smaller number.
That's fine.
But it is possible.
Negative 18.
Nope.
6.8. 72. One with negative 3 campers. No. Will the camp run with 9 campers? What about 3/5 of a camper?
I mean, it could, but there's no such thing as 3/5.
They get sued.
Okay.
Yes, we've already
We've
already proved that was wrong.
If they are an
The Missouri Compromise has already been done away with. Okay, let's keep going. What about 15? Let's talk about tennis camp instead. Will the tennis camp run with 15 members?
Yes.
0.8 people.
No.
4 people.
You have to have at least 5.
Correct. They'll only run if there's at least 5 campers. So 4 would be impossible. Camp wouldn't run. If there were no campers, camp wouldn't run. 25/4 of a people wouldn't run. 0.001 people
No.
wouldn't run. Negative 18. 6.8. 72. Why would 72 not run? Because it has to be less than 16, right? Any questions there on the possible and impossible? Only 2 possible. Input is Kelvin. The input is Celsius.
Yes.
So can you have negative 3 degrees Celsius?
Yes.
Yes, you can.
Below freezing.
Can you have 9 degrees Celsius?
Yes.
3/5 of a degree Celsius?
No. Well,
Has to be visible, right?
would you count? But you don't count. You just count whole numbers when you're doing temperature. Unless you're doing like specific mathematics.
You just count whole numbers in temperature?
Most of the
No,
time.
because when someone has
No,
a temperature like at the doctor's
yeah.
office, they have like, it's like 97.3.
Yeah.
I hope it's not that low. You might be sick.
Mom was today.
Uh-oh, wait, I might never take it. 90.
90.
That's low.
It's low, but it can be lower.
Okay, so is 3/5 a valid temperature? It is. 3/5 is a valid temperature.
What?
3/5 a degree. 15 degrees Celsius. 0.8 degrees Celsius. 4 degrees Celsius. 0 degrees Celsius. Hope you don't have any water. 25/4 degrees Celsius. Yeah. 0.001 degrees Celsius.
If you really want to be specific, yes.
Hope you don't have any ice. Negative 18 degrees Celsius. 6.8 degrees Celsius. 72 degrees Celsius. All those are valid.
So what, is there anything that would be impossible for this?
Yes, that's a good question. Is there any impossible Celsius temperatures? There is. I don't know if y'all know about the Kelvin scale, but Kelvin, do y'all know the difference between Celsius and Kelvin?
Yes.
So one of them is harder to use?
Celsius is 0 degrees is 32 degrees Fahrenheit. It's where water freezes. So it's not as cold as it gets, but 0 is like significant in Celsius. In Kelvin, we take the Celsius number and we add 273.15 because Kelvin has what we call absolute 0, where it can't get any lower than that temperature. So if you put anything less than negative 273.15, you'd be below absolute 0, which is not possible. So
why don't we just use one thing, like Fahrenheit? Why do we have to have Celsius?
well, because Fahrenheit is the dumb one.
Because
Celsius is the one that makes, no, it's easy because you're an American. Everybody else uses Celsius in the whole world but America. And you know why we don't need it? Because we're America. We can do what we want.
Nobody cares about Kelvin.
I ain't learning no other way. Everybody knows there's 12 inches in a foot, and there's 3 foot in a yard, and there's 4 quarts in a gallon. I mean, all these things you have to memorize. 16 ounces in a pound. All these crazy measurements. Do you know what the metric system is? Tens. There's 1,000 milliliters in a liter. There's 1,000 kilograms, or there's 1,000 grams in a kilogram. Everything's a base of 10. It makes so much more sense. Did they ever fly the moon? I don't think so. We did it with feet and yards. Miles. How many feet are in a mile? 5,280 feet in a mile. How many meters are in a kilometer? 1,000. I mean, you have to learn all this. How many yards are in a mile? 1,760.
That's easy.
This is simple.
That's simple.
Would be I input a 5, I got out a 25. And you can see that on a graph. 5, 25. You can also plug it into the function. What happens if you plug in 5 to s? What is 5 squared? The output. You see that? You got 2 ways you can do it. You can either look at the graph and pick a point, or you can plug any valid input in for s, square it, and get the output. So somebody want to share another pair they found?
4.520.
You put what? Say it again. 4.5 and 20. And I'm going to say you got that from the graph. Okay? So if I go to 4.5 and up, it looks like I'm really close to 20. Right? If I'm not 20. But if you want to be real technical, put in your calculator, what's 4.5 squared? It's 20.25. Right? So really the point should be 4.5, 20.25. That's why it's hard to tell on the graph unless it hits exactly on a crosshair. And I mean, it looks like that one does, but it really doesn't. Right? So again, why it's not always best to look at a graph. Sometimes it'd be better to plug in. But I would take this answer for what we're going over today, but in actuality, this would be 20.25. Does anybody else have another input-output value?
I put 6 and 36.
636. If you input a 6, 6 squared is 36. Anybody have a different one they did? These are not the only 3. 749. You said 5.5 and 30. Really close again. It's going to be a little off though if you really plug it in. You could have put in 1 and 1. 2 and 4. Could you put in fractions and decimals? If you wanted to. So before, we said all possible inputs. So the things that we could put on the x-axis had to be greater than or equal to 0. We said it had to be greater than 0. Right? We said 0 didn't make sense because it wouldn't be a square. What would be the set of all the outputs? So what are the areas? Well, what's the lowest output you see here?
0, 1.
So output is just the y's. So what's the lowest y value you see? 0. What's the highest y value you see? 50. If I were to expand this graph, would it keep going above 50? Yeah, just because there's a cap here, we see this graph would continue to do this. What's the highest ceiling you could get to?
A billion, a trillion, a quintillion.
It would go higher than that. Right? You can't put a ceiling on it. So that means it goes all the way to infinity. It keeps growing forever. So we would say the range or the list of outputs is anything bigger than 0. That's the way we could say that right now. We'll get more formal the more we learn. So before, we were asking for possible inputs. And we could put 20 in for n. Now, if 20 is an output, where does that go? Where's my output? The output is the y, which is the whole thing, r of n. So could we make the revenue be equal to 20? Can 20 be equal to 40n? Well, let's see. Let's solve it. What would I have to do to get n by itself? Divide by 40. N is being multiplied by 40. So I need to divide both sides by 40. That would tell me n equals 20 divided by 40 is 0.5 or 1/2. What did n represent here? N was the number of campers. This says in order to make $20, the number of campers needs to be half. Well, can you have half a camper? No. So is 20 a possible output? No. What about 100? Can we make $100 from campers? Let's think about it. If there was one camper, I would make 40. If there was two, I would make 80. If there was three, I would make 120. So is 100 possible? No, I would be between there. 80 to 120. I can't actually get to 100. I can make more than 100. I can make more than 20. But I can't make exactly that number. That's because there's gaps in my values. Do you understand the gaps? Like here, you can't have half a person and you can't make $20 or you can't make $100 because this is represented by a whole people, so you can only plug in whole numbers. Get used to teaching this. Here are two graphs that relate the number of students and camp revenue in dollars. Which graph would represent R? And explain why the other one could not represent R. So which one of these represents what we just got done talking about? The second one. Why is the second one a better representation than the first one? It has gaps. It has numbers we can't get to. It also doesn't include inputs of 4, 3, 2, or 1. Where here had inputs of 4, 3, 2, or 1. Right? And it has all those inputs in between 4, 3, 2, and 1. And all the other numbers. So hopefully that makes sense. And then what's the set of all possible output values? Well, we said it was going to be from 200 to 640?
Yeah.
Outputs are from 200 to 640 in increments of $40. Right? So 200, 240, 280, 320, 360, 400, 440, 480, 520, 560, 600, 640. I did it. What are all the possible outputs for R? So we said the lowest number of campers was 5 they would take. So if they took 5 campers, what would be the output? They would make how much money? $200. Okay, and then what's the next lowest output that they could get? That would be for 6 campers. If there were 6 campers, it would be $240. Because what are they making? $40 for every camper. If there were 7 campers, they would make $280. You'll see where I'm getting these numbers from? You can also do it from the graph. I am actually doing it from plugging in. Remember, it's 40n. If you look up above it, it says R of n equals 40n. So I plugged in 5. I plugged in 6. I plugged in 7. 7 times 40 is 280. 8 times 40 is 320. 9 times 40, 360. 10 times 40, 11 times 40. 12 times 40. 13 times 40, 14 times 40, 15 times 40, 16 times 40. But I can't go to 17 times 40 because 17 is too many. So this is the set of all possible outputs.
I'll just say,
If the camp wanted to make at least $500 from participants, how many students can they have? So originally the lowest possible value was 400. And that was for, no, that's a lie. Lowest possible value was 200. Right? And that was for 5 campers. So now we want to bump it up to where the minimum is 500. So how many students can they have?
13.
It's how many?
13.
13? What's 13 times 40? 520. So we finally got over 500, right? If we need to make at least $500, we can go up to where our output was 500 and find where we finally cross that threshold. Right here we're beneath 500. Here we're finally above 500. Right? And this value is 13, 14, 15. That's how you can see it on a graph. So here's a function. Oh, gosh. F of x equals 6 over x minus 2. To find out the sets that are possible of input and outputs, Claire created a table. And she picked some x's, and she's going to plug them in. It says along the way she ran into some trouble. Oh, no. So I want you to find f of x for each x value Claire listed. And describe what you think Claire's trouble might be. Oh, no. Poor Claire. So fill out the chart.
Being retarded?
No. Do you guys know what you're doing?
Sure. I'd like to.
Negative 10 is an input. It's an x. So where do we plug in negative 10 at? For x. And we find out what y is, which is my f of x. So if I plug in negative 10, you do this in your calculator. 6 over negative 10 minus 2. Does everybody remember how to pull up a fraction?
Yep.
On your calculator. So what did you get? 6 over negative 10 minus 2 is negative 1/2. You think Claire's got some problems yet? No, looks good. Okay. Plug in 0. 6 over 0 minus 2. Negative 3. Claire got any problems there? No, okay. Plug in 1/2. 6 over 1/2 minus 2. Negative 4. Okay. You have to put a fraction in that fraction. Yeah.
I can't. It's in my blood.
Plug in 2. 6 over 2 minus 2.
Error. Syntax error. That's just error.
Can't divide by 0. So it gives you a 0.
Okay.
You do,
Syntax error.
I think.
No, we're mad at error.
Circle slash.
Our problem
No
is,
solution. No
well, it's possible to solve.
When you divide by 0, it's not really no solution. But if you're in the right frame of mind. There's a difference between all these different words that are just random. Let's try 8. 6 divided by 8 minus 2.
That sounded like a song.
It is. It's in your subconscious. So what do you think Claire's trouble might be? Plug it in 2. Math. Yes.
She's sad.
And what was the problem when we divided by, or when we plugged in 2? 2 minus 2 is 0. So you have 6 divided by 0. So that's a divide by 0 error.